Well, thank you for that. I didn't pay them a whole lot. That was really cheap. It cost me like $20 or something for those reviews. So if you ever need them, I've got some contacts. Also, everyone should just look next to them on the chair. There should be like a little green pouch of lollies or something there. You can't eat them now, but after the session you can. So little tip from, is it Catherine or Katharina? Anyway, all right, I'll stop my lame jokes. Okay, me. My name's Matt Follows. Thanks for the introduction. I am a principal product manager at SmartBear. I did co-found Pactflow, which is a startup we'll be talking a little bit about today. My other startup, if it was Jobs Find You, is that what you're looking at? Yeah, that didn't go very far. Learned lots of lessons there. Oof, terrible. But I'm also a co-maintainer of Pact, which is an open source tool, and Pactflow was a commercial offering around that. That was acquired by SmartBear back in April, and we're part of that family now. I'm going to start revisiting this article from a long time ago, and I think it's really appropriate to be at this conference because Dave and the YOW team have been very supportive of this tool ever since it was started. I think there's been 3 or 4 talks there. But the idea of consumer-driven contracts, it was about this time 16 years ago that a guy named Ian Robinson penned this article on Martin Fowler's blog, and it was called Consumer Driven Contract. And he was basically talking about a time where, or I guess in an old architectural landscape where the state of the art was this SOA SOAP-based architecture, and this new or this more common way of doing things wasn't living up to the standards or that it purported to solve, right? The problems it was trying to solve. And I'll read you a couple of quotes just because I think it's really apt to set this whole scene up. He said, chief among the benefits of service enabling an enterprise's application landscape are increased organizational agility, reduced overall cost of implementing change. An SOA increases organizational agility by placing high-value business functions in discrete usable services, and then connecting and orchestrating these services to satisfy core business processes. And it reduces the cost of change by reducing the dependencies between those services and allowing them to be rapidly recomposed and tuned in response to unplanned events, which I think just sounds really familiar, especially after the talk of serverless as well today. But he does continue. He says, a business can only fully realize these benefits if the SOA enables services to evolve independently of one another. And to increase those service independence, we build services that share contracts as opposed to types or objects. Contracts here he's referring to, in this case, WSDL back in the SOAP days, and XSD and XML and all those constituents as part of that technology at the time. And he calls those provider contracts, right? Because they only reflect what the provider sees of the world, not everything else. And he goes on to describe many of the reasons as to why these benefits weren't fully realized in practice. And he talks about hidden coupling and versioning and a whole bunch of things in this space that means they couldn't get that. And he goes on to talk about this alternative strategy, which is what he called consumer-driven contracts, and how it can help you evolve your services independently over time. Let's fast forward a generation of technology, and RESTful services are really the new thing, right? And microservices are becoming this, fast becoming the architecture du jour. And however, it of course had challenges as well. And so in 2014 at YOW, this conference in Melbourne, my colleague alongside Evan Botcher, and I think one other speaker as well, unveiled a tool called Pact. Now, Pact was built in 2013 at realestate.com.au, where they were embarking on this microservices journey and were, I guess enjoying the benefits of this new architectural approach. But were finding it very difficult to test and release that system. And they realized the insights from this article actually applied equally to RESTful services as equally as it did to SOAP. And they subsequently open sourced that tool and made that available to the world. And that's kind of where my story with Pact begins. It was 2014. It was my first consulting client at my previous job. And I saw Pact rolled out, and I was part of this rollout on a project there, and it was just transformational. And I got really excited, I got involved, and became a contributor at that point in time. So, as a consultant, I was very lucky. I got to work at a lot of Australia's largest well-known companies and sort of see their architectures evolve over time. And, I guess there's been a lot of technological change in just my career, which is 15 years or so. And I've seen SOAP architectures on SOA to REST and microservices, to the rise of public cloud, IoT, event-driven event streaming, all of this, and of course, serverless architectures as well. And I found in many of these organizations that the practices and principles from contract testing still applies to those types of architectures. However, we would roll out contract testing, I guess, in a lot of these projects as well. And during the rollout, however, I'd often be on the other end of some snarky comment saying, if we just used, over here, if we just used insert some blank technology, then we wouldn't need contract testing, right? Is REST the problem, is what he's trying to say. Is it true? And so today we're going to examine this statement. We're going to see, is it REST really the problem? And could we save ourselves the trouble of having to write contract tests, for example, by just using more superior technology? We'll look at what contract testing is, what problem it solves, and why it exists. And then we'll also look to see if history is repeating itself. Are these newer technologies actually solving the problem, or are they really not, and they're solving other challenges and other problems we need to solve, but they still haven't solved this exact issue. Specifically, we'll look at three types or three classes of technologies. We'll look at specifications, so things like OAS or async, and of course SOAP. We'll look at IDLs, so things like protobufs and Avro and Thrift. And then we'll look at GraphQL, which is kind of in between. And of course, there's other technologies as well, but by and large, these are definitely the most common suggestions from these other consultants maybe, who suggest that the contract testing could be replaced. And of course, we'll also see how Pact has evolved over the course of 8 or 9 years since we unveiled that. Don't know why I'm clicking on the keyboard, I've got a thing. Okay, so let's start with modern architecture and try to understand why contract testing came to be and how it, in which context it operates. And I want to start with a customer quote here. This is a Pactflow prospect from last year or so. And I think it really helps set the scene for the kinds of challenges that we face as engineering leaders today. And you can sort of read through the quote in the background, but to protect the innocent, I won't say his name, but I will call him Bill. And Bill is in charge of about 40 teams in a large banking institution. And you can see here, he's looking for a way to test and release what is very much a complicated environment. You can see he's working inside a volatile set of integrated environments. He's finding it really challenging to give themselves confidence. He's looking at things like contract testing to help him solve that. And he says between direct calls to RESTful or GraphQL APIs or messages on Event Bridge and Kafka and third-party integrations, he's like, it's just difficult to manage. And I think what you can take away from this is that this is what we're facing today. It's very complex, large architectures, distributed architectures. And really, honestly, when I spoke to this guy, I felt like a psychologist. And he was like lying on a couch, psychiatrist. And he was just kind of had to get it off his chest. And I just felt like I had to somehow console him. And I felt like, I was like, probably not going to be able to help you, but yeah. And I really couldn't reassure him, but I did, obviously. And if this sounds a bit like what you guys are up to, or your organization is, or architecture is, you're not alone. The research from SmartBear's State of Quality report recently highlights a whole bunch of issues here. So the first one is we see that API growth from microservices is going to be, over the next few years, the largest source of APIs going forward. So 61% said that, and 81% said they operate in a multi-protocol environment, and 60% or thereabouts said they do 3 or more protocols. Similar story from Postman's State of API report, where in addition to that, they found that internal microservices are being created. So not for external use, but literally for sharing data and use cases internally, which I think really reflects that shift, similarly we've had with public APIs over the last decade or so, where there was a big shift to start producing public APIs to power ecosystems externally. I think we're seeing that same shift internally for internal microservices. So there's a lot going on beneath the iceberg. Maybe there's another mullet version of that. Of course, though, there are some challenges, and both reports show that there's a big issue with experience or skills around building microservices, as well as the complexity of those. I think about 35% said the complexity of services were starting to become a challenge for them. And 1 in 2 said the increasing demands on speed of delivery as well as a limited time to actually do that testing is becoming an issue. So cycle times and lead time for change are becoming issues. And what I found really interesting was that the mature organizations were the ones who were feeling this the most. So the ones who reported already being pretty mature with writing APIs were the ones who were experiencing the most pain when it comes to that, which might sound a little bit counterintuitive, but I do think the reasons for this are actually pretty well known. And one of the reasons for this is kind of how we test microservices today, and I guess why it doesn't scale. And the way most people do this, or most organizations do this, is what we call end-to-end integrated test. So what that basically is, it involves deploying everything, whole application stack into a staging environment, which we just heard about, right? And then running a battery of tests, right, through the whole thing. And of course, requests have to pass through all the different layers, send emails, talk to systems, whatever it is, right? And that takes time. But if you get to the end of it, you're going to feel pretty confident that your system is working as expected, right? Because you've tested the thing, hopefully. Of course, it comes with a bunch of downsides. And one of those downsides is that this kind of testing is slow. It's very fragile. So it just takes you one element of this test setup for it to all fall apart. Like the wrong data, you might have had the wrong config in a test environment. Joe might have walked past the CI server when it was running, and that just, this is the kind of flakiness that comes in these kinds of tests, right? They're hard to debug. So when something falls apart, let's say it fell apart in microservice B, well, you're going to use encapsulation here and information hiding. So that error is not going to bubble up to the outside. So someone's going to have to go debugging through Splunk or Sumo or what have you to try and find out what went wrong. You need these production level debugging skills to fix this. That obviously takes time. And of course, if you test everything this way, you deploy everything into an environment and test it this way, then you have to deploy everything together. And if you do that, you probably don't get the benefits of microservices. You've probably got what we call a distributed monolith. And the end result of all this is you have teams waiting on other teams. And as soon as you have that, you have queues, and we know from agile theory and lean theory, queuing is going to cause all kinds of problems in terms of team velocity. And so what happens is, as you incrementally add teams and applications and people into your ecosystem and evolve it over time linearly, you get a non-linear response to things like, or the cost, complexity, time, or number of environments, build time, the risk associated with change, and developer idle time. And you can see why Bill's having such a hard time, because he's got to 40 teams and however many hundreds of components. And there's just such a large gap there at the end of that graph. It's got to a point where it's all just too hard to manage, and the systems are falling apart. And so what we would say he's got is a very unbalanced test pyramid. I'm sure you're all familiar with the test pyramid. Things at the top give you higher confidence, but they come at higher cost and higher fragility. And the things at bottom give you less confidence in terms of the overall system, but they run much faster, they're much cheaper, and they're much more reliable. So you want to try and find some balance is the point here. But what we find is the end-to-end tests just occupy too much of the pyramid, so it's really kind of upside down, it's poorly weighted. And what this means is we don't have the agility that we would like. This kind of overinvestment reduces that agility and increases the overall cost of software. So paradoxically, the architecture that's supposed to actually give us more freedom, make us more nimble, cost us less, make it easy for us to change, is actually making us significantly less nimble with every single node that we add into the system. And so one of the solutions to this is using contract testing, and this is where that comes in. So contract testing is an alternative approach to testing the API communication paths between systems. It's not a functional test, but it's about making sure systems can communicate effectively to one another. And really what we do is we look at the integration points. You look at an architecture diagram, you find the arrows, and that's what contract testing aims to solve. And the way it works is essentially you create a unit test on the consumer side, and you mock out the back end. You run your test and you turn that into a contract, but later on, we're going to verify that those mocks are actually real by testing it against the real provider. And we're going to go through that in just a second. But what that means is it's much simpler, right? You're just testing a single integration point at a time. You don't need to deploy into dedicated test environments. You can get fast, reliable feedback. And we get tests at scale much more linearly. And of course, because we're testing things independently, we can deploy them independently as well. The way it works is we still want to get this benefit of fast, reliable, deterministic tests. But we don't want the downsides of that. Of course, if we're using mocks, Well, mocks can drift from reality, which means that we can't trust them. And so that's why we do things like end-to-end tests to validate that our mocks are actually correct, right? We have these different types of tests. Well, with contract testing, we can try to have our cake and eat it too. So what we do is we have two separate unit tests on either side of an integration point, and we write the test against a mock. But what we do is we serialize that mock essentially into a contract that captures all the interactions that this consumer needs of a given API. And that creates our contract, which we share. And there's various ways to do that, which we'll talk about in a minute. And then on the flip side of this, once the contract has been shared, we can pull this back down on the provider side, use this information, and now we know what all of our consumers are doing with us or need from us, and we can replay them against the provider. And if the provider responds as expected, we now know that those two systems are able to communicate correctly. Obviously, Pact is an example of a tool that implements this framework. We won't go too much through this slide, but that was kind of the problem it tried to solve, essentially, 8 years ago. And obviously, it's evolved since then. But it's used in things like JavaScript web applications, so Vue and Angular and React, mobile, services, service and APIs, RESTful services, MQ, and all these kinds of things. So let's look at some of the key ingredients of a Pact test, because it's going to be really important for us to then compare to some of these newer technologies to see if they're going to be able to help us. So here's the ingredients of a Pact test. We're going to go through this kind of line by line quickly. The first key element is we have a scenario for this. So it's kind of a BDD-esque kind of setup. We're going to give the scenario a name. In this case, a request to get all the open orders. We also specify the preconditions for this test to actually be able to function later on. So in this case, the precondition is that there are orders to be fulfilled. Critically, we don't specify how that needs to get set up. We just specify that it is an important state in the system, and we leave it up to the provider later on to work out how they want to do that. So it's still some level of coupling, but it's way less coupled than something like an end-to-end test that would literally need to first create all the orders to be fulfilled, and then check later on if they can be fulfilled and do that. We then set up the mock. So in this case, we're mocking out an endpoint that responds to a get verb, and it will return back, some orders. And then, of course, the really important part is we're actually going to unit test this. We're going to write a unit test for this piece of code that makes a call to get the orders, and then checks that, the way the internal model works, it corrects it all. Yeah, I've got more time than that. And so the goal here is not testing the API provider, it's about testing the API client. And we call this type of testing specification by example, and this is really important. If the client doesn't do what it's supposed to do, it fails. It's a mock, it's not a stub. And again, this is important because we want to be able to create unit tests that are very specific, that are targeted and precise, as opposed to broad brush tests that all start to overlap and become very unwieldy to manage. Once it passes, of course, we get a JSON file in the case of Pact, and that captures all these integrations. And this is going to be the critical artifact that's going to get shared and used around to be able to help make sure things all work together. We can share this thing in the case of Pact through our Pact broker. That is going to contain a visualization of the contract, but it's going to contain the integration point, the test it has, and we can also capture metadata, so things like the version or what environment it's been deployed to, which will become important later on when it comes to evolving this. On the provider side, we talked about this before, it's going to pull these contracts back down from the broker. Now we know all the consumers we need to satisfy to get our job done. And we're going to, Pact will stand in for the consumer now, replay those interactions against the provider, and if it responds as accordingly as expected, or as according to the contract, we know that the integration is good. We know it's safe. And again, this information is going to go back up to the broker. We can see which versions of which applications are compatible with one another. So, version AC1 blah, blah, blah is compatible, and this version, which is annoying on this diagram, has the same version, is incompatible, right? So now we can start to evolve our system safely, knowing which things are and are not compatible. And lastly, we can build up graphs and diagrams and things. We know what the ecosystem is we're testing together, and we know what the visible surface area has been used. Okay, so coming back to the pyramid, hopefully we believe that argument. We really need to significantly reduce our reliance on end-to-end testing to be able to be agile. It doesn't mean there's not a place for end-to-end testing. It doesn't mean it's not useful. It's not universally bad or good. It just is what it is. It's expensive and it can do certain things really well. And if we can just reduce the size of the pyramid and just shift those further up, it means we can get a lot more feedback far left in the cycle than we are getting currently right now far right of the SDLC. And we can do that by adding contract tests to replace the kinds of end-to-end tests that we're just trying to work if the APIs can communicate. And I'd also encourage, just a side note, in my experience, most end-to-end tests that I see tend to do a lot of things, and they can probably just be pulled out and put into standard integration tests or functional tests of those systems. And usually those two things alone can significantly speed up your pipeline. What's going there? Okay, did something. Okay, so now we've got a grasp of kind of the problem and what Pact is trying to do and how it solves things. Let's return back to that original hand-waving argument from my consultant interlocutor and ask the question, is REST really the problem? And really, could we save ourselves the trouble by using some more sufficiently advanced technology? We'll start with OpenAPI and other specifications because this is probably familiar to this audience, but also a very common argument. And it also applies to things like async API and other emerging tech. The way specifications aim to solve this problem, and for those who are familiar with them, specifications are basically a document, usually, that both human and a computer can read, or the machine readable, and they might be domain specific. So in the case of OAS, it's an API-specific specification. In this case, it uses JSON schema, which will basically define the kinds of inputs and outputs an API can have. So given this shape of data, this is the constraints around it. And of course, because it's machine readable, we can use that to our advantage to generate either client code or server code or both. And so the obvious question here is, if we can generate code from specifications, how are we ever going to drift? Aren't we guaranteed to always have a working system? And of course, the answer is no. And if you're at least as old as I am, and you've experienced SOAP before, then you probably have seen that you had all the same ingredients. It had a specification, which was WSDL. It had a data format called XML and XSDs as a schema. And we still had the problem. We still could generate code, but it was still not solve this problem. And to be fair, even though REST does have a lot better principles built into it, it still suffers the same kind of thing. The issue is that schemas are kind of abstract. And so even JSON schema goes on to talk about if you're going to validate any complex data structure, you're going to need to do it at two levels, at the structural level and at a semantic level. And JSON schema can do the structural level, but it can't do the semantic level. A first-class application really needs, a language would really need to do that. So in the case of SOAP, it had schematron, and schematron basically used XSLT, which had functions, right, to solve this problem, or to help solve the problem. The aphorism that an API is not incompatible with a spec, I think sums this up kind of nicely, in that it's easy to say an API is compatible with a spec, but it's very difficult to say an API implements the spec. And the reason for that is a spec's actually quite abstract, despite it sounding like it's not. There's a few classes of problems here that can highlight how abstract these things are, and that Twitter quote from a colleague of mine might be helpful. The first one is with optional and nullable fields. So if your API does have optionals in it, either on the request or the response side or both, you now have in a situation where you're not sure when they're going to be present or not. And oftentimes, they can be present and not present in different situations. So now you have this unspecified behavior that's there, but we don't know how it's going to work. And they might be important to certain users. Combine that with polymorphic endpoints and status codes, and this issue gets really complicated. You can see how it would be very difficult programmatically to say, have we implemented all this? I'll skip past that. The second one is loss of sight of the API surface area. So if you're using SDKs to generate your code, especially your client calling code, then you have to assume that your consumers are just using your entire surface area, right? Because you don't know what they're actually using. They've just been given this SDK, and for all you know, they're using nothing or all of it, but you can't tell unless you look at logs or something. And so this means you need a mechanism for versioning and to evolve things safely. So usually, sorry, I said evolution, but I meant versioning. We'll talk about versioning in just 1 second, but versioning is the standard approach to this evolution. And the last one is around SDKs themselves. I was talking to one of our solution consultants in Europe, And he works with some of the world's largest Open API or Swagger customers and Swagger Hub customers. And he told me that about 90% of the customers who use CodeGen will actually only CodeGen the first time round, and then they'll modify the client afterwards. And so there's still this opportunity for drift between what is happening in reality and what they've done in code. Ooh. Sorry. So on versioning, very quickly, versioning is the most popular strategy for things like OIS, as Postman survey shows here. The issue with versioning is, as a developer, I think it's a pain in the butt. It's an absolute nightmare. And the reason for that is you need to build a new service, you need to test that new service, and then you need to release that new service. And then, of course, you need to maintain that alongside all the other versions indefinitely. And then you need to work out all of your consumers who are using that version, and over time, you need to actually get them off those old versions, right? And so this all takes communication and collaboration and overhead. And really, if we could avoid it altogether, that would just be great. Okay. So let's talk about the second one, which is interface definition languages, or IDLs. So we're talking about things like protobufs or thrift or Navro and flat buffers. There's a bunch of them. And these things are designed, they have a bunch of benefits, but they're designed with schema evolution in mind. So a lot of them actually have schemas built into them. So Avro, for example, when you write to a file system, you can actually write the schema with it. So when you have a consumer who read it, you use a tolerant reader and you can read the data, right? Protobufs has a similar thing built into the wire protocol. But they both have this forwards and backwards compatibility built into the protocol itself. Similar to OIS, because it's a machine-readable format as well, we can generate SDKs and we can generate, client code. Excuse me, what have I done here? Got to work out how this clicker works. Got my other clicker, I should put my other clicker. If this is the case, then why was it that this was literally the #1 requested open source feature for Pact on our roadmap for about maybe 2 years? And the reason for this is, or the answer to this, is that colorless green ideas sleep furiously. Has anyone heard this statement before? Yep. Psychology people? Yep, good, no, good. So this is a quote from Noam Chomsky, I think 1950s, his dissertation, and basically what he's making the point here is that syntactic well-formedness doesn't actually mean grammatical well-formedness, right? It's a completely grammatically correct statement, but it's nonsensical, it means nothing. And so simply being able to communicate is not enough. We have to be able to understand what's actually going on. And so it's kind of analogous to TCP, right? Just in HTTP world, like just because the bits are making their way across the wire doesn't mean that the HTTP application could understand what was going on. So it's kind of a similar thing here. So the ability for older programs to be able to parse, newer data structures and newer programs to be able to parse older data structures is great, except we still need to be able to understand what's actually happening. So a really good example of this is, let's say we've got an ordering event stream, right? We've got orders going on to a Kafka topic and we've got a consumer happening on the back of that and it's reading all the orders and it's tallying it up based on total, right? Finding the total and just tallying up the orders so we can just get an idea of how much is being ordered every day, for example. And let's say we needed to change the order message going onto that queue to, maybe we'd make split the total into multiple fields, or we would move into a nested data structure, whatever it is. Total is no longer there. Just because the consumer can now read that and not explode doesn't mean that total is not an important value, right? It's still really important. So now we're probably going to get, an incorrect outcome somewhere. This gets even worse when you combine it with things like optional fields. So in researching this talk a while ago, I spoke with a guy who worked for a global payments company that you would probably all know, and they use gRPC and protobufs. And he was telling me about this really, really weird bug that they ran into, where they put out this new change to a merchant service, and this property would basically, they added a new property that would say, enable or disable payments for a merchant. So like, could you be dispersed this money? And what they found was there was these random merchants being disabled. They weren't being given any money. They stopped getting payments. And after a whole bunch of digging, they found that one of the consumers of this service didn't update to improve this and use this new definition. So every time it was making a change to update a merchant, it was inadvertently disabling the payments for it. And it sounds really simple, but it was really nefarious to find, right? Because of this default behavior, it was automatically setting that value to false. And so every time it sent it through, it was disabling these payments. And so as you can see, it's particularly nefarious. It's very hard to find. And it's a good example, I think, where forwards and backwards incompatibility is probably not necessarily a good thing. I think you'd actually probably prefer an explosion. So you'd quickly identify it and nothing bad would have actually happened, apart from the system being down, presumably. And in the version of 3 of protobuf, they've actually gotten rid of required fields altogether, so everything's optional. And now you would have server-side validation where you'd still need those things to be required or not. In some cases, it's going to be useful. So you'd put in validation on the server side. Again, you'd now end up with unspecified behavior where in reality the contract says they're all optional, but obviously, sorry, in reality they're not all optional, but in the specification they are. Okay, so very quickly, we just talked about message semantics and optionals. You still need to think about breaking changes. So even with gRPC, they have these field descriptors, and those field descriptors, in theory, should be really easy not to change. But in reality, if you have like IDEs and refactoring tools, you can actually really easy accidentally refactor an entire system and change the field descriptors. And this actually causes very visible breaking changes. In the case of protobufs over other transports, you still need to think about transport safety there as well. A lot of these IDLs don't have very good type systems. They're usually quite abstract. So think of JSON, you've got strings and numbers and nulls and whatnot, but you don't have things like dates or I think timestamps have been introduced, but you don't have this rich tapestry of types, right? But you might still need those types. And so you might want to make sure you've got protections around those. We talked about a similar problem with OAS is that if we're using SDKs, then we lose visibility into real-world client usage, and the ability to coordinate those changes is still something we need to think about. All right, so lastly, we'll just briefly talk about GraphQL, and then we'll come back to how we can solve this problem. So GraphQL kind of builds on some of the things we just talked about, particularly around schemas. I think it likes to think of itself as a type system over HTTP. It's probably the best way of describing it, and that's one of the great benefits. I think the developer experience around GraphQL, particularly with React, is one of the main reasons why I think people grow to this type of architecture, and particularly around the BFF pattern. It definitely has a better type system than something like protobufs. It also has, purportedly, built-in deprecation features to show that these fields are no longer deprecated and ideally avoid versioning. Unfortunately, of course, it doesn't fully solve the problem. And I'll just quickly touch on a few of the points, which are going to sound really similar now. The first one is that GraphQL is often used at that BFF layer, so it still needs to interact with other APIs. And so you probably still need some mechanism to protect yourself there. Deprecation is at runtime, which is, I would imagine, too late. Versioning is still a thing. So if you have to change or break types, really the only way of doing that is deprecating it, wait for all your consumers to update, or version it. And that's definitely still a thing on things like the GraphQL queries. And again, if you're using SDKs for this type of thing, you're going to lose sight of the surface area that your consumers are actually using. It still has default values, which we know is a bad thing or can be a bad thing, and also see other reasons as to why it doesn't fix it. One quick notable shout out though is to Apollo's deprecation features. I think it's got a pretty cool stuff in its platform. All right, looking at the time there, I think we're okay. So hopefully you've all started to see, I guess, get a bit of a theme here, and all these technologies have some great stuff built into them, but they don't necessarily solve this problem around the API communication drift. And this is no surprise. So let's return back to some of the lessons we can draw from all of this, and hopefully understand why consumer-driven contract testing is unique and has this powerful ability to help combat some of this. The first thing I want you all to walk away with today is that your provider contract is just one view of your API. It is not the API, right? It is just a representation of it, and of course that's obvious. Any observable fact or change in the way an API works will be deemed breaking by certain consumers, and this observation is called Hiram's law. It's not that specifications are bad or wrong, but to think that they fully reflect what the product is and what it can do is really just being naive, to be honest. It's just a narrow lens on what it can do. So while we can't make Hiram's law disappear, we can find ways to reduce the ambiguity, and one of those ways is bringing that consumer perspective into it. And yes, for those who are open source or other contributors, yeah, love this quote. Happens all the time. So returning to contract testing and how it actually addresses this. I like to think of it as this generalized approach to communication testing, API communication testing. And the way, in particular, Pact works, which implements this, I think is really powerful. So the first thing is this record and replay style that we use. Because it gets all the representations of how a consumer is going to use an API, we've got this really clear line of sight about what they actually need and what if we change, we could break. But when we actually test that, we've now got even better confidence that the provider can actually do it as well. And that specification by example that comes for free in this way really reduces the ambiguity in what a provider can and should and needs to actually do. Because we track all these application versions over time and which ones are compatible with one another and the contracts between them, we can evolve our service much more safely. And in fact, I like to think of it as time traveling because really you've got this I guess we call it events over time of all these mappings of the versions and contracts which are compatible, and we can sort of ask the question which ones are compatible with one another, and we can go back and look at old events, and we can work if new versions are compatible. All these things are possible because of these interlinked relationships. We can think about the transport concerns in the case of protobufs because we can bring that into the contract alongside the content itself. We can do typed field matching right down to that field level. We can narrow the types from strings to an ISO date or a semver or whatever it is. And of course, because we have what the consumers are actually using in the API, we know what the surface area is of our system that we need to keep providing. And this gives us our mechanism to evolve, and it means we can avoid things like versioning. Now, whilst Pact doesn't have the native capabilities for all the things we talked about today, all the technologies, what we've done is we've made it extensible now via plugins. So I won't go into the full backstory about sort of why Pact has been extended this way, but the brief history is that as an open source tool, one of the main challenges, which is one of our main benefits, is that we support this across multiple languages, about 10 or 11 languages. So having to implement the logic in every one of those languages for every time we make a change is as you can imagine, quite difficult. And so a few years ago, we embarked on a project which is written in Rust. So where's Tim is over there. If you get excited by Rust and you're interested and motivated by his talk and want to contribute, come and talk to me afterwards. But our Rust core is going to have all the shared capability in it, and we're rolling that out across our languages now to avoid us having to build the same thing over and over. And what we've done is we've extended on that to add a plugin framework into it, which would mean that anybody who's like, let's say I want to test AS2805 or some custom protocol in their organization could build a transport or a protocol or a matching rule and extend Pact to suit their particular needs, whether they make it a public thing open source or just build it and use it internally. Our first plugin we built was gRPC and protobufs, unsurprisingly, because that was the most demanded feature that we had for years because of all those shortcomings we talked about earlier. So let's have a quick look to see how contract tests work over protobufs and gRPC, and then we'll look to see if we can draw any lessons from this. So very briefly, for those who haven't seen protobufs before, this is what a proto file looks like. You can see here, I've cut this right back. It's from Google's Getting Started guide. It's called route guide. You basically punch in a lat long and you can get back. So there's a feature there, get feature. You pass in a point, which is just a lat long, and you might get back a feature, which has a name and a location, which is also that lat long. You can see here what a consumer test for this would look like. We similarly have the same thing before. We have the name of the scenario. We have the preconditions required to make this scenario work. We have the request and response style, the details that need to go in there. In the case of gRPC, that can just be request only. It can be one-way, async, or it can actually be streaming. So there's a few different things there. And then, of course, we have our unit test, which takes the transport and runs the actual gRPC unit test against that and makes sure that our service client works as expected. Syntax is a little bit different here because it's a plugin interface. This is the raw interface, but you can imagine it looking a bit nicer than this as we build on this. On the provider side, what we do is very straightforward. We start the provider up locally. So you can see at the bottom there, we're starting up a gRPC server for the route guide server, and the top in our test there, we're just starting that process up in the background. Excuse me. We create the plugin verifier in this case, and then we just tell the verifier where to find the locally running service and where to go find the Pact file, and then it does its thing. If that test passes, we're going to get something that looks like this. It says, yep, we can read the get feature thing, and the consumer can send the request, we could respond to it with the right shaped data. Of course, if the provider is incompatible with that contract, we're going to get back some form of error here. So you can see that it didn't return back. In fact, you can actually see it's actually parsed the protobuf file and is actually outputting some of the protobuf stuff there. But you can see that it's not returning back a route guide feature and that the matching body is incorrect. In this case, instead of returning back integers, it's returning back a string version of that lat, right? And so this is how we can really narrow those types. And also we can see there, we're getting back an empty string. So protobuf has actually put in an empty value for that. But we actually needed a non-empty string. That's really important to this consumer. Oops. Okay, so summaring up, which I think I'm on time. The key takeaways here. So stepping right back, this multi-protocol internal microservices adoption is really increasing, and in fact it's accelerating. It's going to be the majority of API work for a lot of organizations over the next few years. The lack of standardization for design and test is really contributing to this challenge of what we call microservices sprawl. We talked about Hiram's law, and really just that what your API is not always what it seems, and it's much richer than any specification can give us. And there's ways we can reduce that ambiguity, and that contract testing is one way of doing that, of course. But it's also an approach that can really reduce the complexity of our API testing and reduce the ambiguity inherent, really, in all of these API specifications. And of course, we talked about Pact as a specific example of this kind of pattern and how it really can be used as a standardized way to test APIs across protocols, across transports, and content types and languages. Lost my voice somehow, but that is the end of my talk. Thank you so much for listening. I know it's getting late in the afternoon.
We do have a few minutes for questions. Does anyone have any? You have to put your hands up big because I'm not wearing my glasses and it is late in the day. There we
go. So just excuse my ignorance here. You used the term API surface area. Would you be able to expand on that a little bit? I didn't really infer exactly what you meant by that.
Yeah, good question. So let's say you've got an API that's got 10 endpoints. Let's say it's an ordering API. You've got one to, create an order, get an order, update an order, what have you, right? And let's say further inside that order, you've got an order object which has 50 fields on it, right, from your provider. The consumer may, in most cases, doesn't need to use all of those fields. And it may not actually use all the APIs either. So what we're saying by the surface area is everything that the provider publishes to the real world, that's the surface area of the product. But a consumer is only ever using usually a subset of that. So what we mean by the surface area here is we want to capture exactly what all of our consumers are using of an API, because now we know the things that consumers aren't using, we can just remove. That is not actually required to do our job. Yeah, it's a good question.
Anyone else?
Who here uses versioning as like your standard strategy? Well, not many, okay. Who here hates versioning though? Okay, well, people who didn't put their hand up the first time, yep, still hate versioning, good. Well, if you do have any other questions, feel free to grab me in the foyer. I'll be around tomorrow this afternoon as well. Oh, we have one question here from, yep.
Hey, as it's getting cheaper and quicker to stand up full environments from like your infrastructure as code and stuff like that, like seeing a lot more of a shift towards integration testing as opposed to unit testing and stuff like that. And you said contract testing sort of sits in between, the integration test and the unit tests. So I know you said at the start of the talk, it's like, oh, but if we just use this, then
Yeah.
Where do you sort of see sort of that future landscape heading? Do you see it more heading towards integration testing
it's a great
space,
question.
or do you think contract testing
Yeah,
is like a really good place?
Great one. I used to do a talk on serverless testing and how do you do that, because it's like a lot of it's just YAML, right? You're not going to write unit tests for YAML. Just not going to do it. Doesn't make sense. Integration testing would make much more sense to do. I think the issue is where, we talk about cheapness and all that. It's actually still the complexity that becomes an issue. So I used to have a version of a talk that basically had containers, right? So, we can solve it because we just put containers there. But eventually a machine locally doesn't run those containers, it just explodes. I think it's similar with serverless as well. Like, there's nothing wrong with running it in an integrated environment, but you have to find a boundary somewhere that makes sense. And what we see is organizations not drawing very clear boundaries around that, or the boundaries are just way too big. And there's too many teams in there, and it becomes very non-deterministic to be able to build reliable environments, whether you're using Docker or IAC or CloudFormation, YAML, whatever it is. So I do think, taking away the unit testing aspect of all this, integration testing is still really important, and that's a very broad term as well. So are you referring to specifically in the environment, or more just generally speaking integration testing, where we're making sure multiple things can work together?
I guess, yeah, more making sure that multiple things can work together, because like, as things become more and more granular, like those boundaries are sort of blurring a little bit more.
For sure, yeah. So we're just saying the blurry boundaries between boxes in this integrated world. Yes, I think of Pact as, we try to make it like a unit test because it runs fast and reliable and deterministically for the most part, but I like to think of it as an integration testing tool because that's really what it's about solving. It's about distributed systems that communicate over network boundaries, and we want to give ourselves more confidence we can do that. And contract testing is one form of integration test. Obviously there's other types, and I think they're still very useful. The way I tend to think about it in a general sense, of course there's always going to be specifics, but I think I love the idea of a budget for your CI pipeline. And if your CI pipeline is going past a certain length, then all these really bad things start to happen. So times that lead time for recovery, start batching changes, all those kind of things kick on. And I think sometimes just thinking about time is actually one way of helping you get a better balance.